Hello and welcome to my CS520 presentation 1. My name is Yizhu and my email address is listed here. My topic is why does a 2's complement number act like a negative during addition? To answer this question, we first need to understand the concept of 2's complements. Let me explain this by a chart over here. This is a binary form to integer forms number conversion. If I started with 0 and I added up by 1 and by 1 and by 1 and I add up all the way to 0 followed by 7 ones, the corresponding integer here it's 127. And if I added up one more to this binary value, it will turns out to be 1 0 0 0 0 0 0 0, and the corresponding integer here is negative 128. And we can continue to add 1 to these binary values and by 1 and by 1 and by 1 until you ended up with zeros. So actually if we wanted to represent the negative integers here, we need another form in the binary value, and this form is actually called the 2's complements. It is actually very important to use the 2's complement to represent the negative integers in the binary form. So how can we tell if a binary number is a 2's complement? Let me go back to this chart over here. We can actually find some features of these negative forms and the positive forms. So if this binary number represents a negative integer, it will actually start with ones. And if those ones that represents a positive integer, it will actually start with zeros. And the zero value here is regarded as a positive one here in the binary form because it starts with 0. So we can say that if the first digit of an 8-digit binary number is 0, then it represents a positive integer. And if the first digit of an 8-digit binary form is 1, then it represents a negative integer. Then it is a 2's complement. For an example, this number 11101000 must be a negative, and is a 2's complement. The converted negative number is negative 24. I'm not going to explain how I converted to negative 24 because it's not the topic here today. And how to convert a negative integer to a binary using 2's complements? Well, there are actually several steps. Let me also explain this with an example. Suppose we are working with 8-bit binary, and suppose we want to find out how negative 24 would be expressed in 2's complement notation. First, we write out the absolute value of negative 24 in binary form, which is going to be 0001 1000. Then we inverted the digits, so 0 becomes 1 and 1 becomes 0. So it turns out to be 1110 0111. And then we add 1 to the binary, then it's going to be 1110 1000. So the representation of negative 24 is actually 1110 1000. And it's actually called the negative 24 in a 2's complement. So what will happen if we add up the 2's complement? Let me also explain this with an example. So suppose we want to add these two binary numbers. The first one begins with 0 and the second one begins with 1. So we can actually tell, based on my previous explanation, that the first one represents a positive integer and the second one represents a negative integer. It actually, this one actually represents 99 and the second one actually represents negative 24. So this is actually why when we add up a 2's complements, it looks like that we're adding up a negative number because they are actually negative in the integer form. So the adding results is here. And this is my reference. Thank you for watching. I hope I have explained clearly of why adding up a 2's complements looks like negative. Thanks.